Welcome back to my channel. In this video tutorial, we are going to focus on the AND gate, the OR gate, and the NOT gate. So let's begin with the AND gate. We are going to go over their illustration, their logic circuit, and their logical combination. So what exactly is the AND gate? You need to know that the AND gate works the same way as that of the AND operator. That is, the output will only be true if and only if the inputs are true. So what does that mean? Let's begin with the circuit diagram first. So the circuit diagram of the AND gate looks something like this. So towards the left is the input. So assuming this is the first input, okay, I need that to be quite straight. So assuming this is the first input and it's denoted with capital A, and this is the second input denoted with capital B. Then if the output is Z, then the output is going to be true if and only if this and this are true, that is, they are both ones. So this is the logical circuit diagram of the AND gate. So what about its logical combination? So if you want to represent this in terms of function, then Z is equals to AB. So which means the AND gate acts as if those inputs are multiplying one another, and that is why the output will always be 2 if and only if the inputs are true. So now let's talk about its truth table. How does the truth table look like? Let's go into that. So first we need to have 3 columns. Okay, that's enough for the inputs and the outputs. So this is the first input, this is the second, and Z is the output. So when A is true, when A is false and B is false, what will be the output? When A is true and B is false, what will be the output? When A is false and B is true, what will be the output? And when A is true and B is true, what will be the output in this case as well? So according to the logical combination of the AND gate, the inputs multiplies each other. 0 times 0 is simply 0. 1 times 0 is indeed 0. And 0 times 1 is also indeed equals to 0. But 1 times 1 is equals to 1. So therefore, the conclusion that the logical AND gate is true if and only if the inputs are true is absolutely correct. So that's just how it works. Just make sure you keep that in mind. It will only produces 1 when the inputs are 1. And that's how the circuit diagram also look like, because we are still going to be going over some circuit diagram problems whereby we will be transforming circuit diagram into a logical combination or a function. So let's talk about the second one, which is the OR gate. What does the OR gate mean? What is the basic idea behind it? For the OR gate, you can always see it as the same way as that of the OR operator as well, as it is only false when both the inputs are false. Otherwise, this gate will always produce a true outcome. So let's see how it works. First, what is its visual illustration in terms of circuit diagram? How does it look like? The visual illustration is quite different from that of the AND gate. And here is how it looks. Hopefully I get that properly. I think it's pretty much okay. So this is the output. Let's assume it is Z, and the inputs are going to be towards the left. So let's assume the inputs are X and Y. Or typically, let's use what we used earlier. That's A and B. A and B. So this is a visual illustration of the AND gate circuit diagram. So keep that in mind. Whenever you see it, you should know that it's serving or standing as the OR gate rather, to say. So what about its logical combination, its logical function? How can we express this? It's different from that of the AND gate. In this case, Z is equals to A plus B. So it means you assume those inputs are adding one another. So we are going to show this using the truth table. So how does the truth table of the OR gate looks like? So just like before, let's form 3 columns. So first one, second input and the output. When the input is false, when it is 2, when it is false, when it is 2. And when this is false, when it is false, when it is 2, and when it is 2. Now, when A is 0, B is also 0. 0 plus 0 is indeed equals to 0. But 1 plus 0 is 1, and 0 plus 1 is also equals to 1. And finally, 1 plus 1 will result in 1, according to the logical addition rules. So 1 plus 1 is going to be equals to 1. That is, 2 statements plus 2 statements will result in 2 statements. So that's how the OR gate works. And that's why they said it only produces a false output when both the inputs are false. Otherwise, this gate will always produce a true output. So what about this last one, which is known as the NOT gate? How does that work? What does it mean? Let's look into that. Also, we are going to talk about its circuit diagram. For the NOT gate, it works the same way as that of the operator negation. That is, it gives us the opposite value compare or relative to that of the input. If the input is true, then the NOT gate will produces a false output. While if the input is false, then the NOT gate will produces a true output. That is how it works. It produces the opposite of what is being inserted into the gate. So how does it look like in terms of visual illustration? And yet how it is. So whenever you see any diagram like this, then she knows that it is the NOT gate. Okay, so it's going to have a little round circle that's going to be open. So the output is going to be here. So the input is way towards left. So assuming the input is A and the output is Z, then Z is the negation or the NOT gate of A. So what about the logical combination, the function? How will we express the function? It's quite straightforward. Z is just equals to A bar, okay, which also serve as a complement, that's just like the opposite. So that's how the functions look like. So which means if you are to draw the circuit diagram of anything that's look like this, then she knows that you have to represent it something like this. And if you are given something to be represented this way, or a function to say, or a circuit diagram, then if you are to transform it to a logical combination, then you should use something like A bar or whatever the input is. Hopefully you grab that. So now, what about its truth table? How does that look like? It's quite straightforward as well. Since we are only having one input, then we're going to have just a columns or 2 columns rather. So for the input and for the output. When A is 0, then the opposite of 0 is 1. When A is false, then 0 will be 2. And when A is 2, 0 will be false. And that is just how the logical NOT gate works. Hopefully, you find this content helpful and understanding. If you haven't subscribed to my channel, please do subscribe. Thanks for watching. See you guys in the next video. In the next video, we are going to focus on the NAND gate, the NOR gate, the XOR gate, and the XNOR gate. Stick with me and click on the next video. Bye for now.